picked this up today. This is a little linear regulated power supply. 3 rails. We've got a plus 5 volt on the left and plus and minus 15 on the right. Adjustable on the 5 volt rail from about 4 volts to about 6 volts, and on the right from about, it looks like about 12 to about 17. Very low output power. I think half an amp on the 5 volts, no, 1 amp on the 5 volts, and 200 milliamps on the 15 volt rails. The main reason I picked this up is it's got one really nice feature, and it's got a plus and minus output on the 15, as you see here, but it also means that it tracks the plus and minus 15. So there's only one control for the 15 volts, and that's that pot on the right here. And what that means is the 15 plus and minus 15 track each other, so there's no individual adjustments of pots for keeping the plus and minus 15 rails balanced. And that's great when you're using you're connected up to a piece of equipment that needs a balanced plus and minus 15 volt rail, and it's quite important you keep those 2 rails in check. So yeah, these things are pretty cheap. This is the Farnell Tops 1. There is a Tops 2 apparently, which is slightly higher power. As I say, basic regulation. The pass transistors are on the rear and pretty well heat sunk. The condition of this unit is in pretty good condition. I have powered it up. It does work. There are a few things I want to sort out though. It's probably going to need a recap, and also it looks like the 1 amp current limit's a bit premature on the 5 volt rail, so that's adjustable. And I managed to find the manual on how to set it up and things. So we've got a couple of warning lights here, basically for when the unit's in current limit, and just to warn you that you're at the limit of, and it's going to start folding back. There's constant, no adjustment for current limit, so it's a constant current power supply up to an amp where it will just fold back. So yeah, this should be a nice little power supply just to keep on the bench. It's compact and small. It's the mains plug in the back. And I think they do these for 115, 220, 240. The fuses on the back as well. The good thing about linear power supplies like this, they're very electrically quiet. They generate very well. They don't generate any RFI interference. They're great for things like ham radios and things. Though this wouldn't probably produce enough power to drive a ham radio, but it does mean that the signal it does produce has got no birdies on it. It's basically a clean, non-switching waveform on here. So I think what we'll do is we'll start by taking the top off, having a poke around inside, having a look, and seeing what needs replacing. I know that these knobs here are a bit rickety. You can really see that, but they're a bit worn out and knackered. I can find some pots quite easily. That should be fine. I've measured them. I took the cover off and measured them. They're about a 1k wire wound, so I can find those easy enough in our stores at work, because we've got bags and bags of them from our old equipment that we don't use anymore, and all that stuff's about to be got rid of. So managed to find some pots for that. So let's get the cover off this, have a quick look inside and see what we've got. Okay, you see inside it's pretty straightforward, basic layout. Phillips capacitors that probably need replacing. There's a German cap here that's probably also needs checking at least to see if that's okay. We've got a fuse down here that protects the 5 volt rail. I think that's over current on the 5 volt rail. It also has somewhere, I can't see where it is at the moment. Oh, there we go. Just here, I've got a thyristor here, which acts as a crowbar to, because this is a linear regulator, if the 5 volt pass transistor goes short, you get sort of probably 7, 8, 9 volts, and the idea is that crowbar will fire and short the outputs out and protect your equipment downstream, sort of thing. So here are the 2 pots here, and you can hear they sound horrible and grating. So I want to replace these 2 pots. One of the first ports are cool, and then we'll put the capacitors on the ESR meter just to see what they measure, and if they are poor we'll change them. We might up beef those up a bit actually. And what I would also like to do is see if I can possibly get away with a bit more current out of here. It'd be nice to sort of, this is 200 milliamps, if we could get half an amp out of it. I think we're pushing it a bit with the size of those little transformers. But 400 milliamps, 300 milliamps would be nice. Always nice to squeeze a bit more out of it. Might be able to get away with that by just heat sinking those TO66s or whatever that package is, these two transistors here, and just sort of put it on the bench and see how it performs. You might not be able to get it to regulate at that sort of current. You might find that sort of you get dropouts. You'll find that the header volts and the transformer breaks through and you'll get a load of ripple on the output. That's usually what happens when you try and push these too far. So yeah, the first port of call is I'm going to get these pots out and replace them with something a little bit nicer, something that's not quite so worn, and we'll have a tinker around, see how it performs. Okay, I started to take the pots out and realised the knobs weren't actually done up very tight, so they're tight now. So I haven't replaced the pots, they're fine. They're a bit scratchy, but these wire wound resistors always are. So we're just having a look at the capacitors. That'll be the next port of call, and these couple of Phillips here, and these are the two capacitors for the plus and minus 15 volt rail, and the other capacitor here, this German thing here, is the 2200 at 25. This is the schematic for it, and these are the two 470s. There's one here, and there's the other one is just here, and then we've got the 2200 on the 5 volts, which is just there. So what we're interested in doing is checking the capacitance and seeing if the thing is actually sort of dried up at all. So I've connected it up to my HP 4261 bridge, and we're looking, it's pretty good. It's measuring 484 at 0.08 dissipation factor, so that cap test's really strong, so there's nothing wrong with that. And I've got a feeling this probably hasn't had an awful lot of use. Let's try the other capacitor. Wait for it to range. Similar sort of thing, 468.07. I know a lot of people out there seem to think that you should recap everything as soon as you buy it. I don't believe in that. I don't believe in recapping stuff just for the sake of it. I believe in replacing capacitors if they're faulty or they're failing, but I don't believe in just shotgunning capacitors just for the sake of it. And I know a lot of people out there don't like tantalum capacitors. I've got no problem with tantalum capacitors as long as the rest of the unit's healthy. And as most people know, that tantalums only fail when they see a bit of ripple current. Okay, so this is the 2200. Okay, so it's measuring 2300, and the dissipation factor is slightly higher, but it's still perfectly acceptable. So it does leave us a couple of these other smaller capacitors here. Now let's have a look, so we can get any of these. Now these are ones that I am more likely to change because they're more likely to fail, these smaller value capacitors. Let's try this. This is C11 on the 5 volt, but that's measuring 110 microfarad and 0.1 dissipation factor. So let's see if we can find C11 on this circuit. Where are we? C13. C11. So it says it's supposed to be 47 at 10 volt. And it's measuring 110. That's pretty because it's across. Oh, here we go. It's across this other capacitor here. So we've got two capacitors in parallel. We've got C11 and C12 in parallel with a 680R resistor. They're on the output, so that's the output smoothing for the 5 volt. So we're looking at, we should be over 100 microfarad, and that's what we're seeing. So those caps check good. No problem there. So it looks like this instrument is pretty good. I think the next thing to do is to power it up and have a look on the scope with a bit of a load on it and see what the waveforms are like and see how the voltage tracks. Let's do a quick voltage check to make sure the output's good. So this is the 5 volt rail, and it says there's the setup in the instructions, but basically you just wind the pot up so it indicates the right position on the pot. So turn this to 5 volts, so we see that that's on 5 volts, and the output's putting 5.04. That's good. Just turn it up to 6 volt. A bit further, 5.99 volts. So that the voltage tracking is good on that. So that's the 5 volt checks okay for voltage. Let's go to the minus 15. Okay, and let's turn that up to 15 volts. That's spot on 15 volts. There's your minus 15.08. That's good. Plus 15, 14.98. Okay, so that's okay, but we could probably pull that back in with the tracking control adjustment. We'll try that in a minute. Let's wind this to 17 volts. About there. We've got 16.95. Bear in mind the connections aren't great on this because I'm just holding them in. And we got 17.11. So a tracking adjustment probably needs a bit of a tweak here. So I think we'll have a go at that now. And what it says is to set the control to 15 volts. Get your 15 volts on the scale here. Now, find our tracking control adjustment. So tracking control adjustment is, where are we? The top one, balance, I think it is, this one here. So we're looking for P1 on the board. So we need these two voltages the same. So we've got minus 15 on this one, minus 15.06, and I've got minus 14.96 here. So we're only slightly out. We're about 10 millivolts out, 100 millivolts out, sorry. So we'll just give that a tweak. So we can find P1 in here. Wonder where that is. It's P6. Looks like it's this control here nearest me, so let's get a little screwdriver. Let's get in there and give that a little tweak, so we can try and get that as close to 15 volts as we can. Get the right screwdriver. Bear with me whilst I try and get the bloody screwdriver clean. One of these touchy adjustments, I think. Not adjusting that very well. 14.96, 15.05. So I think I'm going to have to do this off camera because it's hard to hold the camera at the same time. See if I can get this a bit better. Okay, simple adjustment to make. You set the minimum voltage at sort of 12 to 13 volts, and that's 17 volts. That gives you a sort of like a reasonably accurate scale throughout the range. The balancer control is set now correctly. So this is the minus 15, and we've got minus 15.03. See, and the plus 15. 15.00, and it's crept about a bit slightly. It's not going to be perfect, but it's within a few millivolts now, a few tens of millivolts. That's good. The other thing to do is check the current limit circuit works, and that is basically all I do is I stick the fluke in amps range, and it's 0.17 amps, and you see the current limit lights on there, showing that the thing is actually in fold back at the moment. Let's try it on the other channel. It's the minus rail. Same thing for the minus rail. 0.18 milliamps. 0.18 amps. Sorry. So that's 180 milliamps. So it's a little set a bit low. I'm not sure that's adjustment. The adjustment controls are all set here. Yeah, it's not adjustable on this model. This is for the Tops 2 I was mentioning about previously. So there's no adjustment for current limit on the 15. Really, if the power supply has been designed correctly, I can leave that in short circuit mode all day and it will not cause any problem. It should be suitably underrated where nothing's going to get warm. I've got my hands on the heat sinks, they're cold still. It's probably very derated, this thing. I'm sure you could get a lot more out of it, and it's be pretty easy to achieve that as well. Let's go to the 5 volt rail just quickly and just see what our current limit is on that. and that's 0.6 amps. Now that's well set very low. So I'm just seeing if we can adjust the 5-volt current limit. Yeah, P6, we can adjust that. So we're going to try and bring the current limit up to 1 amp, because 660 milliamps is not really awful lot. I actually might try and push that a little bit higher and see if anything gets hot. So let me just find the adjustment. So it's P6. That's P6 at the back here. Let's wind this up. Okay, there's 1 amp. It will go higher. Well, I think we'll leave it at 1 amp for the time being. So that wasn't particularly well adjusted. Good, leave it for 1 amp for the moment. We'll go back to volts range. Now bear in mind, when you're measuring current, you can't normally do this. You can't put a short circuit across an output unless you're sure that the power supply itself is actually a constant current supply. So let's increase this to 5 volts on the control, and we see there's 5.07. I think what I'll do now is I will go back and check the current limit now at a higher voltage, just to make sure it's, sometimes they're not very linear. So let's go to the 10 amp range. Yeah, that's pretty good, just under 1 amp, so I'm quite happy with that. So I'm going to leave that short circuited for a couple of minutes, just to make sure nothing's getting hot. This obviously this heatsink is just getting tepid to the touch, so but it's nothing. That's one of the driver transistors. That's warm. Nothing to worry about at all. So it looks like this is a perfectly working power supply. The ultimate test will be to put it under a bit of load and see what the ripple's like. But initially, it looks like it's going to be a nice little power supply for the workshop. So let's get the top back on it. I'll leave this on for a soak, just to make sure nothing goes up in smoke, and then we'll have a go at seeing how good its output is. I'm connected up to the 5-volt output. I connected up to a wire wound 10 ohm resistor, so that's 5 volts into 10 ohms, that's half an amp. And we're looking at the output on the waveform here, and we're at 2 millivolts per division, and we've got bandwidth limiting on because there's a bit of high frequency noise coming through from stuff picked up from lights and things like that. But you can see our ripple is below 1 millivolt, which is superb. Even in a modern power supply, 2 millivolts from a 5-volt power supply is very, very good. So you can see clearly that the ripple is very, very low. There's no noise, there's no high frequency noise. You haven't got any nasty sharp edges or anything. Make a really nice, clean power supply. Let's just adjust the voltage slightly. You can see the scope's capacitor coupled, so it's just settling down. Well, now I'm going negative. That's turning it down. That's turning it up. Nice, smooth, clean output for a very low ripple, no instability or anything like that. Obviously it's only a resistive load, but that's clearly working quite nicely. So I think the thing to do next is to check the 15-volt rails and see how they perform. They should perform just as well, really, because it's basically the same circuit with a different transformer and a few different components. But let's swap it over and have a look. We need to change the resistor value, obviously, because we're limited to 200 milliamps, and obviously our voltage is higher. We'll be drawing 1.5 amps if we try to connect it up to this 10 ohm resistor. So let's get that sorted out. So jerry rig this up to a suitable resistor to give us about 150 milliamps draw. Okay, this is a 150 ohm resistor across the 15-volt load. So that should give us more or less 100 milliamps, which is basically half the rating of the supply. We saw earlier that the 15 volts wasn't really capable of giving you 200 milliamps, and that could be adjusted probably by a couple of resistors, but it looks like there are no actual presets that we can adjust, so there might be some select on test resistors, which are basically a resistor that you can adjust when you set the machine up from the factory. I'll have to have a look into that, but it's adjustable some way or other. But at the moment, let's have a look at this. So we've set it to 15 volts, 15 ohms, 150 ohms, so we should be drawing 100 milliamps. Now you can see a little bit of low frequency instability there. You can see that time base down so you can see a bit better, and you can see a bit of low frequency oscillation there. It could be a number of things. It could be a bit of 50 Hertz breakthrough from maybe a capacitor. It could be just the response of the loops not that great, but by what I mean is the feedback loop is not reacting quickly enough. But to be honest with you, with a fixed load like this, it should be pretty stable, so it's probably more likely to be a bit of 50 Hertz breakthrough, something like that. But that's pretty good. That's on the minus rail, so let's swap it over to the positive rail. Have a look at that. And yeah, similar sort of thing, maybe slightly less. So pretty clean output actually for that. And this is between the two rails. I don't know if this will actually work. In theory, yeah, that should be 30 volts now, and you can see the resistor starting to smoke quite nicely. So we must be close to current limit here, but I'm not sure how it detects the current. I'm hoping that it detects the current quite nicely, but a bit of magic smoke coming out of there. You can see that for all you people who get their rocks off on seeing something smoking. Resistor's obviously over dissipating, but the ripple's still good. So it looks like that supply is pretty capable when it up to full voltage. No problem there. It looks like maybe that supply is actually capable of giving 400 milliamps when it's at 30 volts. I'm not entirely sure of the configuration. I wouldn't have thought that was possible, but yeah, nice little power supply. This quite pleased with that. It might be nice for sort of testing, sort of like old car radios and things like that, when you don't need an awful lot of current. Certainly a good sort of power supply to get you going, and once you've got the sort of like the radio repaired, you can actually use a higher powered power supply. You're pretty safe with this because you know you're very limited in current. Anyway, I hope that was interesting. That's the Farnell Tops 1 power supply. I picked this up for I picked this up for £10 on eBay. I'm sure there's others out there. A nice little bench power supply.